Hello and good day, geometry. We are wrapping up our unit on similarity, talking about dilation. So triangles come up here, but more just any type of polygon on the corner plane. And a dilation is a type of transformation. Before we start recording, we brought up words like rotations or turns or slides or things like that. All of those are other types of transformations. But a dilation is a similarity transformation. Okay. Most other transformations that you can think of, you remember doing, did the size of the shape change? No, only its position, right? You rotated it, you moved it, right? But the size didn't change. With the dilation, you are enlarging or reducing a figure proportionally. You are enlarging or reducing a figure proportionally. Thus, that's why it's a similarity transformation. Okay, we're dealing with scale factors here. And the scale factor of a dilation, it's notated using the variable k. Okay. And what that represents, it is applied to the ordered pair of the figure. Okay, so when you see a k in an ordered pair, it refers to that scale factor. And the notation for a dilation would be given ordered pair xy, so its original position. You're going to see an arrow because we're changing it, right? We're transforming it, and that scale factor k is going to be applied to each variable in the ordered pair. So it's going to be k. I have like a dead spot on my board there. Kx and ky. Okay, kx and ky. Tell me if I need to slow down here. Are we all good? Okay. You will know that your figure is going to be a reduction, meaning it's going to be getting smaller if your value for k is less than 1. You know, if k is like 0.5, then your new figure will be half the size. If k is 0.3, your new figure will be 30% the size, right? It'll be getting smaller if that scale factor is less than 1. It'll be an enlargement. It'll be getting bigger if the scale factor is greater than 1. Now, scale factor k value of 3 means it's 3 times the size. It's going to be getting larger. Why can't k equal 1? Right? We have k is less than 1, k is greater than 1. Why can't k equal 1 for dilation? Blake?
It wouldn't do anything.
It wouldn't do anything, right? It would stay exactly the same. So in order for it to be a dilation, it has to be a similar figure. It's got to be proportional. And if k was 1, that means you're not doing anything to it. It's staying the exact same size. Right? Yes. Finally.
What?
Someone said something I say makes sense. It's a big day for me. Okay. All right? Questions on this so far? All right, let's practice. It might help you to get out 2 different colors just to kind of plot these points or just label them well. Okay. But it says complete the table, plot the original figure ABCD, and then plot the new figure, and you're told that k is equal to 2. Right? So k equal 2 means that that's going to be the scale factor from your original figure to your new figure. So in this dilation notation here, xy will become 2x and 2y. Right? K equals 2, so we don't write k. We plug in 2 for it because we're told that's what the scale factor is. So let's plot point A first. And I'll do this actually I'll do it in red, and my new figure will be in green since I wrote that in green there. Okay. So point A is at 2, 1. That's going to be right there. Right. What's the new point A going to be of my new figure? Well, 4, 2. right? And we get that by applying that factor of k, multiply our x value by 2 to get 4, multiply our y value by 2 to get 2. Right? It's twice the size. And then that order pair, 4, 2, that's going to be right there. Point B is at 4, 1. I'm going to plot that point right there. 4, 1. And what is the order pair of my new figure going to be after applying that scale factor to 4, 1? Drew? A2. Excellent. Right? Multiply 4 by 2. Multiply 1 by 2. And we get 8, 2. So I'm going to go all the way over to 8 and 2 and plot the point. Point C is at 4, negative 1. So 4, negative 1, going to be right there. And what is my new point C going to be? Applying that scale factor of 2. Anybody else? Caleb?
8, negative 2.
8, negative 2. Right? Double the x value, double the y value, and we get 8, negative 2. And finally, 1, negative 1. Plot that point. 1, negative 1 is going to be right there. What's the order pair of my new value? My new order pair going to be scale factor. Joey.
2, negative 2.
2, negative 2. So that's going to be right there. It can get a little bit crowded, so you gotta watch for that. Right? Just keep track of stuff. That's why 2 colors helps. But now, when we connect the dots of our red figure, our original figure, got to calibrate there, I think, and then connect the dots of our new figure, our green figure. Okay? That green figure is twice the size. Questions on that? Fairly straightforward. Think we can handle this? Okay. Questions on this before I scroll down?
No.
Okay. So the next one is similar. You got figure ABC. This K, the scale factor is 1/2. So whatever order pair is given to us, to find our new figure, we'll be taking half of x and half of y. You're welcome for keeping all these even, right? So you don't have to deal with any decimals. But again, that k, that scale factor is whatever your original x is, take half of it. So our original point A, 4, negative 4. Let's go ahead and plot that right down here. What's the order pair of our new figure going to be? Original 4, negative 4, scale factor of 1/2, half of x, half of y. Blake? 2, negative 2. 2, negative 2. And that's going to be right there. Point B, 8, 2. I'll plot that in red. 8, 2, all the way over here. And what is the order pair of my new figure going to be? Scale factor of half. Peter?
4, 1.
4, 1. Good. Put that right there. And lastly, 8, negative 4. That's going to be down here. New order pair? Somebody I haven't heard from yet. Okay, let's keep this new participation going. I've heard from you. Nathan?
4, negative 2.
4, negative 2. Thank you. Okay, 4, negative 2 is going to be right there. And so this time, our original figure, what's in red, is going to be larger, right? We have a reduction here. We're reducing the size of that, and we know it's going to be a reduction because that k is less than 1, right? Our similar figure, our proportional figure, is half the size, right? Our original figure has a base length of 4. Our new figure, base length of 2, half the size. Original figure, height of looks like 6. New figure, height of 3. Half the size. Okay? That's how dilations work. Who's had their eyes dilated before? What happens when you get your pupils dilated? They're super big, right? No? That's where that word comes from. Okay. Next page. Similar one for you to work on. The scale factor is 2/3. So you know it's going to be a reduction. Again, you're welcome for making all these ordered pairs multiples of 3 to make dealing with that 2/3 a lot easier, right? And then below that, you've got a figure with a scale factor of 5/2. So you know it's going to be an enlargement because that scale factor is greater than 1. Okay? It's going to be 5/2. That last section, though, it says find the scale factor from figure ABC to figure LMN. How are we going to, if this is our original figure here, ABC is our original figure, and LMN is our new figure, how are we going to go about finding the scale factor? This time where we're given the ordered pairs, and we want to figure out what that value of K is. How do we go about that, Joe?
We gotta use proportions.
How, Joe?
Just set up a proportion.
And you have in mind?
Really? 18/9, then 12/6.
Okay, and so 18/9 and 12/6, those both equal 2. Okay, which tells us that those ordered pairs are proportional, but is that the scale factor? Okay, the question that we're asking ourselves is, how do we get from point A to point L? Like, what's done to this 12 to get to that 18? What's done to this 6 to get to that 9? Right? Because that's what that K value is. It's how we get from the original value to the new one. So how do you get from 12 to 18? And remember, it's got to be with multiplication or division. Really multiplication because it's your fractions. So Drew?
Multiply by half.
Half of 12 is 6. So if we multiply 12 by half, we get 6. Not 18. We're on the right track. Nathan? Multiply by 1.5 or multiply by 3 halves, right? 3 halves of 12, 3 halves times 12 is how you get to 18. Now, how do you come up with that other than just like guessing and checking? What's a method, Nathan? Did you just guess and check until you found it, or did you have a procedure? Yeah. If we're looking for how we get from 12 to 18, right? 12 times what number gives us to 18, because that's what K is. It's that number that we're multiplying by. We solve this equation by dividing both sides by 12, and n equals 18/12. What does 18/12 simplify to be? 3 halves. Right? So to find that scale factor, if you're looking for how do I get from my first ordered pair, my first x value, to my second, you really just have to take, I shouldn't say that, not y, but your second x divided by your first x. That's how you can find k, right? Your second x or your second y divided by your first y, that's what's going to get you to k. And it works for all of them, Even if we take this one down at the bottom here, our second y, -33, divided by our first y, -22, -33 divided by -22 simplifies to be positive 3 halves. Right? So I give you 3 ordered pairs, but the scale factor is going to be the same for all of them. So you don't have to do it for every single one. You can find it just by looking at your first ordered pair, then maybe picking one from a second or third order pair just to check your answer. Make sure that scale factor matches your first. But this is your formula to find scale factor, right? You're taking your second x value, dividing it by your first x value, or your second y value, dividing it by your first y value. Okay? Because that's going to tell you how you got from x1 to x2 or y1 to y2. Does that make sense? Right? Algebraically, as an equation, it looks like this. Maybe I shouldn't use n. Maybe I should use K, right? Here, 12 times what scale factor? 12 times K gives me an 18. You solve that by dividing both sides by 12, simplify the fraction, and you've got K. Okay? Okay. Questions, comments, concerns, complaints, compliments, congratulations, criticisms, or clarifications? Blake,
Great job.
thank you. Appreciate that. Yeah. Build my self-esteem. Anybody else? Blake?
$900.
I used up all my money to make this. Okay. Homework for Monday is to finish CO38. You'll get your practice test on Monday, answer key on Monday, test Tuesday and Wednesday. If you finish your test Tuesday, you want to start your takes Wednesday, then great, but we'll plan on finishing up this unit Wednesday, retake days Thursday and Friday of next week. Good? All right. Have a great weekend, folks. That's my math.